Hello, I'm glad to see you again. Welcome to Module 8. In this module, we are going to talk about a very powerful module, Numpy. Numpy supports a wide range of mathematical operations on large, multi-dimensional arrays. To use Numpy, we need to import it to your program. To use a function in the library, we need to call the name of the library. Let's type import numpy as NP. We can use the as function to assign an alias to a library to save the time of typing its full name in the later operation. We can use numpy to import files from other sources. The loadText function loads a text file into a numpy array. Each row in a file should have the same number of values. Remember to put lecture8.txt in the right place first. See Module 7 for details. So first, we upload the file lecture8.txt. Then we type data equals np.loadText lecture8.txt. So for inputting a dataset, we better to use pandas to do it. There are several functions for us to create an array. The array function creates an array with the data inside the bracket. First, we create array 1 with 1, 2, 3, 4, 5, 6. And they are integer. Then array 2 contains 1.1, 2, 3, 4.5, 5.6, and they are floating. Array 3 have 2a, 3, 6, and numbers inside are integer. The zeros function creates an array based on a given size and type with values of 0. So here, array 4, numpy zeros, 4, 6, and d type integer. And you can see that now we have 4 rows and 6 columns, and the data types are integer. The fill function replaces all value in an array with the number inside the bracket. So here, we type fill 8, and you can see that all numbers are filled with 8. The reshape function can change the number of rows and columns of an array. The reshape function can change the number of rows and columns of an array. So here, array 5 equals array 4 dot reshape 38. So we want to reshape to a 3 row and 8 columns array. Then we try to reshape it to 92 to see what's happening. Remember that the new array should have the same size as the original one. Otherwise, error would occur. But remember, the reshape function does not create a new array. So let's try to type array 5, 1, 1 equal sign 1. And we try to type array 4. Now you can see that actually the value in array 5 is changed as well. Why? Because here we didn't create a new array. We just try to arrange the original value in array 4 in another array. So if you change array 5, the value in array 4 will still change. We have to bear in mind the differences between a copy of an object and a reference of the object. The front code does not create a new array, but creates another name references to the original array. So let's type array 7 equal array 5, array 7 dot fill 9, and array 5. Now you can see that all values is actually replaced by 9, because array 7 is actually just a reference for array 5. So to create a new array object, we can use the copy function. Let's type array a equal array5 dot copy array8 dot fill 10. And when you type array5, you can see that all values keep as 9, not 10, because now we only change the value in array 8, not array 5. To get a portion of an array, we could use the slicing operation by providing start, end, and step parameters. In the slicing rule, the start position is included, but the end position is not included. Let's type array9 equal np dot array 1, 2, 3, 4, 5, 6 integer and array9 0, 5, 2. So here you can see that we're actually starting from the number with index 0 to index 4. So it means we have 1, 3, and 5. And you can see the 2 means that you are going to jump for one value to get another one. So it means the middle one will not be counted. We can also select a two-dimensional array. First, we type array10 equal numpy array, the first row 1, 2, 3, the second row 4, 5, 6, and the third row 7, 8, 9, and they are integer. Then we type array10 1 colon 2, and when we run it, you can see that actually we get the second and third row, because first parameter refer to the row that you're going to get, and then the second parameter refer to the columns that you're going to get, which is with index 0 and index 1. So it means the first column and the second column. Then we type array10 1 colon and colon, and we run it, and here you can see that we are actually getting the second row, third row, and all the column. The concatenate function can merge multiple arrays into a single array. Let's try to learn how to combine two one-dimensional arrays. First, we type array11 equal numpy.array 7, 8, 9, 10, and they are floating numbers. Then we type array12 equal numpy.concatenate array9 and array11. So we are going to combine these two arrays. And we type array12 to run it. And you should be able to see that now we actually combine the two arrays. Array9 has number 1, 2, 3, 4, 5, 6, and array11 has number 7, 8, 9, 10. We can also merge two two-dimensional arrays into one two-dimensional array by setting the parameter of an access. The default way of merging is by column and putting the second one under the first one. If the access set to be 1, merging will be made by rows and the second one will be in the right hand side of the first one. Let's learn how to combine two-dimensional arrays. Here we already have two arrays, array 13 and array 14. Now we type array 15 and equal numpy dot concatenate array 13 and array 14. And type array 15. Now you should be able to see that we are actually combining two arrays by column. So it means they have the same column but adding more rows. Now let's learn how to combine by row. It's very straightforward. You just need to type access equal 1. And now let's save our array into array 16. And then if you run it, now you can see that actually the two arrays are combined by rows. When we show array 15, you can see that originally we combined it by column. We can compare an array based on some criteria and return an array with booleans called a boolean filter. We can also compare an array with another array with the same shape. So we already have two arrays here, array 17 and array 18. Then we type array 17 larger than array 18 and we run it, and the program will going to track all the elements. So you can see that the first three numbers of array 17 are larger than array 18, but then for the last two is larger than those numbers in array 18, so it shows true. We can also compare all values in an array with a number. Let's type array 17 less than 5. The first four numbers in array 17 is 1, 2, 3, 4, so they are less than 5. Therefore, they are true, but not the last one, 5. 5 is not less than 5. And we can also use logical statement to try to set multiple criteria. Here we set array 17 larger than 18. At the same time, the number should be less than 5. So you can see that only 4 meet the criterion. Then how about we try OR? If we use OR, what will happen? You can see that the first 4 numbers is less than 5, so they're true. And the last number, 5, is larger than the value in array 18, so it's true as well. The where function can utilize the Boolean filter for other operational purpose. So Numpy where create an array with the same shape as Boolean filter, whether the true Boolean will be replaced with true value and the false Boolean will be replaced with false value. Let's try to type numpy.where array 17 larger than array 18, 1, 0. So you can see that in this operation, whenever array 17 is larger than array 18, it will show 1. In case the values are not larger than those values in array 18, it shows 0. We can select certain elements from an array to form another array by indicating their indices in the original array. Let's try a one-dimensional array. Here we type array 19 equal numpy.array and 5, 10, 15, 20, 25. So you know that index 0 is 5. And then we type array 19. We want to get number with index 0, 1, 2, 3, 2, 1, and 0. So we are going to get the first number, second number, third and fourth number, and then third, second, and the first number. For a two-dimensional array, we have to specify both the row index and column index. For example, for array 20, we have the first row 1, 2, 3, the second row 4, 5, 6, and then the third row 7, 8, 9. Now we are going to get some number. So let's use the first number as an example. The first number with the row index 0, it means the first row, and with the column index 2, it means the third column. So first row and the third column, it means 3. Then let's try to use the Boolean filter to select some elements from an array that meet a specific set of criteria. Here we have array 20, which we want to get all the numbers that larger than 5. Now we get 6, 7, 8, and 9. Numpy does arithmetic operations for array on an element-by-element basis. Remember, when we do arithmetic operation for arrays, the shape of the arrays being operated should have the same shape. As array 21 has 1 row and 3 columns, so array 22 should also have 1 row and 3 columns. Here, when you type array 21 minus array 22, you should be able to see that the differences of each number is -3. We can also do arithmetic operation for two-dimensional arrays. So here we have two arrays, array 23 and array 24. And let's type array 23, asterisk, asterisk, array 24. If you still remember, it means that you're going to the power of all numbers in array 24. So let's take an example. 6 to the power of 2, we got 36 for the first one, And the last number, 1 to the power of 12, it will still be 1. But there is an exemption called broadcasting. So let's type array 21 divided by 2. You can see that now you actually divide an array with a single number. Or you can recall what is array 22, which is one row with 3 columns. And array 24 has 2 rows and 3 columns. But when we type array 22 add array 24, it will still be fine. It's called broadcasting, and you can see that actually we add the numbers in array 22 to the all columns in array 24. Table 1 provides a list of mathematical operations in Numpy. The following table provides a list of commonly used statistical functions. We can calculate summary statistics for elements in each row, each column, or in the whole array. I hope you enjoyed this module. If you want to know more about how to do the operation, I would suggest you to try to do the following exercise. Thank you for watching today. I'm looking forward to see you in the next module. Bye bye.